Hey there, welcome back for more Advent of Code. So today we are continuing on where we left off last time. That would be, I confused the URL. That would be day 19. So, day 19, not enough minerals. Well, I get that StarCraft reference. I always like the voice of the Zerg commander. How was it called? Like the hive mind, something like that. That said like, we require more minerals, and it was so epic, the StarCraft one. So I guess this is a reference to that. Okay, your scans showed that the lava did indeed form obsidian. Wow, nice. The wind has changed direction enough to stop sending lava droplets toward you, so you and the elephants exit the cave. As you do, you notice a collection of geodes around the pond. Geodes are those rocks that have like an interior with crystals, right? Yeah, these things are beautiful. Nice. So, collection of geodes around the pond. Perhaps you could use the obsidian to create some geode cracking robots and break them open. To collect the obsidian from the bottom of the pond, you'll need waterproof obsidian collecting robots. Fortunately, there is an abundant amount of clay nearby that you can use to make them waterproof. In order to harvest the clay, you'll need some special purpose clay collecting robots. To make any type of robots, you will need ore. Okay, I guess this is also, this is kind of like the StarCraft thing where you need ore for any type of thing, or I guess gas also, which is also plentiful, but in the opposite direction from the clay. Collecting ore requires ore collecting robots with big drills. Fortunately, you have exactly one ore collecting robot in your pack that you can use to kickstart the whole operation. Okay, so we have a bunch of robots that collect things, but you need to create the robots themselves. Each robot can collect 1 unit of its resource per type per minute. It also takes 1 minute for the robot factory, also conveniently from your pack, nice, to construct any type of robot, although it consumes the necessary resources available when construction begins. Okay. The robot factory has many blueprints, your puzzle input, you can choose from, but once you have configured it with a blueprint, you can't change it. You will need to work out which blueprint is best. For example, blueprint 1, each ore robot costs 4 ore, each clay robot costs 2 ore, each obsidian robot costs 3 ore and 14 clay, okay, and geode robots cost 2 ore and 7 obsidian, okay. And blueprint 2 is kind of similar but with different costs. Okay, blueprints have been line wrapped here for legibility. The robots factory actual assortment of blueprints are provided 1 blueprint per line. Okay, so I guess the input is just 1 of these per line. The elephants are starting to look hungry, so you shouldn't take too long. You need to figure out which blueprint would maximize the number of opened geodes after 24 minutes by figuring out which robots to build and when to build them. Okay, using blueprint 1 in the example above, the largest number of geodes you could open in 25 minutes is 9. One way to achieve that is minute 1 ore collecting robot collects 1 ore, you now have 1 ore. Okay, so you start with like 0 of every resource and you have the robots that collect on each turn. So minute 2 is the same, minute 3 spend 2 ore to start building a clay collecting robot. Okay, so I guess, here clay costs 2 ore. 1 ore collecting robot collects 1 ore, so So you now have one OR. Okay, the robot and the factory work simultaneously. The new clay correcting robot is ready. You now have one of them. Yeah, this is at the end of the minutes, I guess. Okay, yeah, you start the minutes. This is what happens at the start of the minute, I guess, and this is what happens at the end. Minute 4, you have ore collecting and clay collecting robots. Nice. Minute 5, spend 2 more ore on another clay collecting robot. The new clay collecting robot is ready. Okay, so now you're collecting 2 clay per minute and 1 ore per minute. Nice. Another clay collecting robot. You have now 3 of them. 9 clay. Okay, minutes 9. So it's a bunch of minutes. We can maybe reference this later. Okay, here is something is interesting. Spend 3 ore and 14 clay to start building an obsidian collecting robot. Then you keep making clay collecting robots, and the obsidian one is collecting obsidian. Then you make another obsidian robot, but by minute 16 you have 6 obsidian already, but no geodes yet. And finally here, spend 2 ore and 3 obsidian to start building a geode cracking robot. Nice. Yeah, so you open geodes. And here you construct another one of those. Yeah, because I guess you are collecting quite a bit of obsidian, right? Well, you had... When you make this, you have 3 obsidian at the end of the turn, so then you have 7 and you have enough for another one here. So that's all right. And then you are incrementing geodes by 2. And you end up with 9. That's nice. However, by using blueprint 2 in the example above, you could do even better. The largest number of geodes you could open in 25 minutes is 12. Okay, and they don't give you that example, because I guess you have to figure it out. Determine the quality level of each blueprint by multiplying that blueprint's ID number with the largest number of geodes that can be opened that can be in 24 minutes using that blueprint. Quality level. So each blueprint has an ID, which I guess is just the number, right? Yeah, blueprints 1 and 2. With the largest number of geodes that can be opened in 25 minutes using that blueprint. In this example, the first blueprint ID is 1 and can open 9 geodes, so its quality level is 1. The second blueprint has ID 2 and can open 12 geodes, so its quality level is 24. Finally, if you add up the quality levels of all the blueprints in the list, you get 33. Okay, so you have to add up everything. So you have to compute the maximum geodes for every blueprint. Determine the quality level of each blueprint using the largest number of geodes you could produce in 24 minutes. What do you get if you add up the quality level of all the blueprints in your list? Okay, that's this one seems like a like a pretty complex one. A lot of logic, robots, modeling and stuff. And let's see the inputs. Okay, so this is very condensed, but we have a lot of blueprints, 30 of them. Okay. And it's not like we have to determine which one is the best. We have to compute the quality level for each of them and then add all those up. And we have 24 minutes. Okay. How the hell do we do this? This one seems like a very like way more complicated than the previous one. Like day 18 was just a 3D grid thing that was pretty simple. I wonder like which day of the week this was. Let's check maybe. We are, this would be not January, December 2022. This is 19. It would be a Monday. Wow, this is very very cruel. I don't know actually if the guy who makes Advent of Code, like if he prefers to leave the weekend puzzles easier, which seems to be the case because the previous one would have been on a Sunday and it was pretty easy compared to this one. So he's basically plotting for people to not work at their actual jobs and spend all day solving Advent of Code, which is amazing. Thanks for doing that. I have no idea how to do this thing. Like, should we go try to brute force all the possibilities? Like simulate all the branching possibilities of what to do? Because basically, on each minute you have to make this, how to say, like this logic of producing, like what the, make the robots collect things. That's for sure. But you also have to make the decision of which robots to make or not make any. And you have 3 or 4 kinds of robots. So ore robots, clay robots, obsidian robots, and geode robots. And in some turns you may not make any of them. So you can either make one of them or wait. But in some cases, I guess you can also have the possibility, like, let's see, in this case, with Blueprint 1, we have these robots that cost 4 ore, or these ones that cost 2, but I think we never make, ore collecting robots is just one. The starting one, we never make another one. So this was the most efficient thing, even if at some point we have 4 ore, which I guess at some point we probably have, like here, we don't make them. Yeah, and so it means that at some points you have multiple possibilities. You can wait, or you can maybe make one of these robots or one of these, or maybe if you have a lot of materials, maybe you can make any of these robots, but you have to pick one. So if you imagine this as a tree of possibilities, each node on the tree could have 5 children. Like make one of these, one of these, one of these, one of these, or wait. And we have 24 minutes, so that is, if you do like 5 to the power of 24, it will be a huge number. But I guess most of the times you probably don't need to, or you don't have the possibility. Like when you are in minute 3, the only possibility that you can do with 2 ore that you start is either make one of these, a clay collecting robot, or wait. So in some minutes you don't have the 5 possibilities. I don't know if there is a very clever way of like computing this directly given these starting numbers, or if you just have to bite the bullet and start, like, make the whole simulation. Interesting. Okay. In the meantime, let's start with something simple and let's just parse the input, because also I don't have much time. I have to do something at 6 p.m. So let's go to Advent of Code, and start the editor. Let's add, how was the name? Not enough minerals, or I guess it was that. Yes. Yeah. We have this. Let's make a new file. And as usual, we have the public function run that takes an input of type string slice, and we return. My hands are very cold. A string. Okay. And let's create the input file also. So inputs, this would be day 19 txt. Let's copy this input and change it. I think it's something like this, the format of the actual input. Yeah. Okay. Great. So let's start with something simple and just parse these blueprints, and then we can start to think of how we do the simulation, the very, very branchy simulation. Okay, so let's say let's blueprints be star lines, and I guess the other day I learned a trick, which is what we have been doing so far is to, when we need to do some parsing like this, is to do a map like parse blueprint. Then we have a function that does this and collect these things. But you can also use, like we could also do something like line parse and make the blueprint struct, which we haven't defined yet, but make that struct implement the from string trait, and this parse then would work. But oh, I guess here this should be input, and this parse, yeah, as you can see, the return of this would have to be a thing that implements from string, but we can do it with less, like in a less idiomatic way, but the way that we have been implementing this so far. So parse blueprint. Let's define this function. This will take string slice and return a blueprint, which we have yet to define. So struct blueprint. So how do we define this thing? I think like this simulation is basically all simple numbers, like the amount of ore and clay, like resources that you have on each turn, and the amount of robots that you have on each turn. So like basically thinking of, should we go with something like here it says each ore robot costs 4 ore, say something like or robots or cost, and it will be a number, and then repeat this for the other costs, or have something like more generic, like or robot cost be a, I don't know, resources, and resources would be like a struct that could be or clay blah blah blah, which would be what we have on each minute. The thing about doing that, yeah, I don't know. I think I would prefer to start with something more specific and direct like this, and then see if it makes sense to generalize or not. So clay robots or cost, then you have obsidian robots, obsidian robots or cost, yeah, and the obsidian robots also have a clay cost. My face here is annoying. Yeah, and 14 clay, 7 obsidian. Yeah, okay. And nothing costs. Well, there are some pretty high costs here. I do have this. Some things cost like 12 or 11 obsidian or 18 obsidian. Like, I wonder if, or in this case 20. This one is, it's very interesting. Like, you have 24 minutes. You're never going to get, I think, 20 obsidian, because you have to wait 4 minutes to get clay. Yeah, and then you can have obsidian. Like, these blueprints, I wonder if we can do some like short circuiting, or like, I'm pretty sure that this we can say you are never going to generate any geodes with this blueprint in 24 minutes. And for others, you also need like 17 obsidian, and this needs 14 clay. Yeah, and yeah, there's no way also, I think, that for 19 you're gonna get any. So I'm actually thinking of what part 2 will be like, because part 1 is already quite complicated. I wonder if part 2 is going to make things like last longer, more minutes in the simulation, so you have to really optimize. Man, I don't know. Let's try to get something that sort of works first. So you have this, and after the obsidian you have GeoRobots cost or an obsidian. Okay, so let's have these 2 lines copied and say that geode robots, well, or cost and obsidian cost. Okay. So how do we parse this then? I guess we could do something sort of clever and try to parse things that look like this, and, you know, sort of like regular expression kind of thing, but I don't want to use any external library or anything like that, and I think I know a little trick that can be useful for this, and which I think we have already used in previous puzzles, which is to just split every word here and try to parse it as a number, and then just retain the numbers, and that's it. So what we'll do, I guess this can be called line, because it is a line, and we can say line split, and here the pattern from splitting, I think you can pass either a string or different characters to split, because I think, no, it wasn't dot, but I think we want the resources, which are these numbers, and this number for the blueprint, I think, yeah, which would be the ID, and we haven't put this here, but ID, which is a small number, so I guess we can just use a byte, why not? I trust the compiler to do the, I don't know, correct padding and things to make these things efficient. So yeah, we're going to split this and do map, and each word we're gonna do word parse, and say let's numbers be this thing. We don't want to do unwrapping here. I guess we can keep the result, and then there was, I think, a way to extract this filter map, I think it is. What does this do? It takes a function that no, I don't want to. I think I don't want to. Oh, maybe I want to do filter map here, right? Yes, okay, so it's the same as doing a filter. This is basically what we want to do. It's kind of the same example. They are parsing a string, strings, and filtering the ones that parse correctly, and then unwrapping them. But with filter map, you can do parse, and you have to convert it with OK. I think transforms a result into an option. So that's what we want. So here we want to filter map and say parse OK. So these things should be numbers, since, well, I do wonder about, let's maybe keep it also as U32 to have everything be the same kind of thing. And then we need to collect, and we are gonna collect into a vector of U32. I think we need to declare this, though I'm not sure. Woohoo! Look at that. So we're gonna have all of this, but I think we are gonna have lots of variables named like this, right? Yeah, or maybe we can use, let me think. Yeah, I think we can just use number 0 and so on. I guess this will work. So I would have preferred to like extract this or pattern match the numbers, but yeah, this should work, I think. And of course I should be doing this more efficiently, but who cares? So okay, these are 7 numbers, right? Let's check. 1, 2, 3, 4, 5, 6, 7. Perfect. Okay, so we have the blueprints, I think. And if we well, let's keep this and let's do a print line of these blueprints. I think we can say debug something. Ah, yes, we need to know where we are collecting into. And now it's going to complain about not having like display or debug. Yeah. Hey main derive debug. And we are gonna cargo run 19. Well, it exploded with index out of bounds, index 6. Okay, so let's then print here, println. I guess we have a debug print for numbers. I should get more used to using this thing, which I think is pretty useful. Oh no, don't clone. Yeah, this, I said it was pretty useful, but then it consumed this thing, so I'm not sure if it was. So we only have 4 numbers. Oh yeah, because I made a stupid mistake. This was separated by a colon, semicolon. No, this is how is this thing called? Colon, I think. Okay, yes, we got the blueprints printed. That's very good. I guess that was the easy part of this. And this is fine, I think. Yeah, it's gonna complain about an index out of bounds, which is not the best of errors if things fail. I guess, let me think. This is fine for now, I don't care. Okay, so now that we have this, then what? I guess we can also model the... We're gonna do a simulation that we're gonna start at like minutes 0 or 1 and go up to 24, and or well, the other way around, starting at 24 and going to 0. And we are going to be keeping some state on each minute, right? So maybe we probably want a struct for that. So I think this is fine. I probably don't need to derive debug here. Let's call this thing state. And what are we going to have? Just the resources, I guess, or clay, then was obsidian, and geodes. I'm sort of torn between using plurals or singulars because, like, I think ore is uncountable, right? Like there are no ores or clays, and probably obsidian either. But geodes is very countable. So I think my English is sort of correct here. And then we're gonna have to count the robots. So, or robots, these are nice plurals. So then clay robots, then obsidian robots, and then geode robots. And that's it. I think that's the things we need to keep track of. Okay. Fine. And we can probably, I don't know if the defaults, how was this? Like, you can probably derive defaults here to make it start all at 0. So what we're gonna do, we have the blueprints. We have the states. Let's sketch it up like top down, like the answer that we want. Well, we can say, how was this thing called, like quality level or something like that? Yeah, quality level. Let's say let's quality levels be blueprints, iterate over them, and map. I'm gonna have each blueprint, and for each of them, I guess we can do a bit of sort of object oriented. No, not really. I'm sort of tempted to say like, hey, give me your quality level. And then really don't need to collect over this, just have the quality levels and then do, let's total, was it total quality level? Or the answer, I guess, is gonna be the sum of quality level. Let's quality level sum, or I guess total quality level, which is quality levels sum. And we're gonna print this thing. This is not the way to format things. This is format this thing. Okay. And then quality level. Generate. Oh, look at that. I can generate methods. Awesome. The quality level is what? It's gonna be a number, I guess. So it's gonna be self ID times, and then here I have to decide if I also delegate and say like, hey, compute the max geo. I don't know how is it called, like generate the geodes, largest number of geodes you could produce. How are we going? Like that is the meat of the things here. So what do we want to do? And how are we going to sketch this thing out? I'm thinking of going like with a recursive function that keeps creating states, and on minute 24 and like adding minutes, and on minute 24 it just it turns it returns like on minute 24 it stops recurring and takes the number of geos on that state. And how do we get the maximum? Okay, so let's can I do this? Like to do, I'm not sure how we are going to do that. Let's sketch out like what I want from that function. So max find max geodes for a given blueprint. Well, blueprint, and starting on a given state, I guess. I guess this function would probably want to live either on state or on the blueprint, but we can think about that later. And it returns, I guess, the max number of geodes. So how are we going to do this? We also need the minutes somewhere. Minutes. I'm also going to use, I don't know why I'm using 32-bit numbers. Probably should use 64 since it's like the native word size of this machine. But anyway, we can probably change that later, or I don't think it will make much of a difference. So each time we are going to recur on this, we're going to like add one more minutes. So okay, let's start with a recursion termination condition, which would be if minutes is 24, so we are going to be starting at 1. Yes. Yeah. If minutes is 24, then we are going to just return state geodes. Okay, that's sort of important. That's great. We can also put a to-do here so the compiler doesn't shout at us. Then, what I want to say is something like, well, if I can make or robot, then what? Then let's say that the state, also like the state, there is something that we will always sort of do, and it is to increment the minutes and make the state update with the production that these robots are doing. So I guess this is the termination condition, and I wonder if the minutes should also go into state. I'm not sure, but we can shadow minutes and say, well, is minutes plus 1. Let's new, well, the new state. No, if we want to, like, that's something I think we need to always wait for. So okay, if we can make an OR robot, and this would be a local variable here, which we can compute, then I want to say something like, okay, state, maybe this can be a method on the state, like wait 1 minute, or do the production of 1 minute. I guess this could be called like tick, simply because it's like each tick would be 1 minute, and we're gonna do all of that and make OR robot. Yes. Sure. Does this make sense? Let's say let new state. It's gonna be a state with, I don't remember how it was to like merge a state with another one. I think the syntax is something like this. And or robots is gonna be state or robots plus 1, something like that. Sure. And then we do find max geodes with this same blueprint, but the new state, and well, minutes plus 1, I guess, which we have already shadowed here. Right? Maybe it does make sense to have, because we are always going to tick, I think. But well, we can think of like the sign of this later. Okay, this is complaining because well, can make robots. Let's say let's can make or robot. This is going to be, we can make a robot if the state or count is greater than or equal to the blueprint, or robot or cost. Great. And we can implement this tick on the state, and what's it gonna do? It's gonna do create a new state merging everything in self, so the robots are going to stay the same. All of these, but we are going to increment or by doing states, well, no, self or plus self or robots. Yeah, and then we are gonna do the same with clay and the same with obsidian and the same with geodes. Geode, and I think I missed geodes, yes, and here I missed the robot names. This is the geode robots and this is the obsidian robots. Right? You don't like the syntax? Do you like it when I do this? Oh, we need to... Is this what you want? I'm not sure if this is going to do what I want this to do. I hope it does, like rewriting this and then using these defaults, but we shall see. So it's sticking, and why don't you like this? Oh, because again, like default state. Great, and this is going to be a new state. So yeah, probably this find max geodes should probably be a method on either the blueprint or the state, but we are gonna leave it like this. But here is the one of the branching possibilities, which is to make an OR robot. Now this thing, we are ignoring the result, but we should not ignore this. What we can do, I guess here is the termination condition, but we can do let's max geodes start at 1, and this is going to be a mutable thing, and do max geodes equals max geodes max with this, something like that, and then in the end we're gonna return max geodes, right? Sort of, I think, I don't know. Yeah. We can probably do this and do something similar for all, like the 3 other types of robots, and then do something like if we cannot, no, it's not like if we cannot build any of them, we should always consider the case of just waiting. So that's another case, and we can do, well, basically this, but without incrementing. Well, so I guess it's just going to be this. Just tick here. Yeah, this is gonna be very repeated, like max geos, blah blah. I wonder if we can do something about that. Okay, to do the same for the other 3 robot types. Okay, I think I'll cut the video here and continue afterwards. And I just noticed that my face is frozen, and I have no idea why this happens. I don't know if it's an error on OBS or Linux or whatever. I hate these kind of things that are difficult to debug. But anyway, I'll continue later. I have to take my cat to the vet now. So see you later. Bye bye. No, that's not the shortcut. And we are back. Okay, so let's see where we left off. Yeah, we were doing this find max geodes function, which is like the meat and potatoes of our solution, and we were considering the cases of being able to make an ore robot or clay robot and so on. So here we think implemented the make ore robot logic, and let's let's shamelessly copy paste this. I think yeah. The other one was clay robots. So we will be able to make clay robots if the ore is clay robot or cost, and there was not. Yeah, this is the only cost for this. And if we can make a clay robot, then we make that one and recur. And then we're gonna do the same for the other one, which was obsidian, I think. Well, same thing here. Can make obsidian robots if, well, this is or obsidian or cost, and state clay is greater or equal to blueprints obsidian robots clay cost. Great. Then we make an obsidian robot and recur. All of this is repeated. We can think of that later. Finally, we can consider the geode robots. So geode robot, if the ore is this, fantastic, and not clay but obsidian. Obsidian cost. All right, then we make geode robots. Now I'm thinking the geode robots are should be our priority to get these things as fast as possible and as many as possible. So maybe I don't know if it will make a difference, because we are not doing any intelligent thing to not recur or to prune this recursion tree somewhat. But I don't know. Let's try this. I want to have some solution for part 1 and see what part 2 is about, because I'm sort of dreading what may come from that. So let's brute force it. Anyway, we have this find max geodes. So here, equality level, I guess we can do ID times find max geodes for this blueprint self. State, I guess we can do something like state new, and we have to implement that. And minutes, are we starting from 1 or 0? So we are, I guess we should be starting at 0. Yeah, because like if we should be simulating, for instance, 1 minute, we start at 0, then increment this thing and do the tick, like do the simulation, and then when we recur, it will be 1, and we will return from there. So since we are, I think, simulating 24, it should be this. And yeah, the new function does not exist, so let's generate this. Let's let's move this to the top here. This should generate, create a state. So here we're going to take a reference to that. And I guess here what we want to do is create a state where everything is 0 except the initial OR, which should be 1. So I guess we can also derive default for this. Oops. And do why don't you like this? Oh, I got confused. I thought this was the blueprint. So yeah, state this and state default and merge. Okay. One thing I would like to do is to print this thing. So let's extract this into a variable. This would be max geodes, and let's do println max geodes for blueprints are max geodes, and this would be self ID. Okay. Total quality level. Come on, cut. Explicit type, yeah. Quality level, yeah, we're using youth32 for everything. Probably should change that to 64, but let's use it for this too. Oh, what did I do? Okay. Okay, can we run this? I sort of expect unbounded recursion, to be honest, but let's go. Or just 0. Okay. And this we didn't explode, but we got 0. Are we not recurring? We are, no, we are also incrementing the minutes. Okay. We are passing this new minutes thing here. Sure. So what's going on here? I do wonder if this state new is doing what we... Well, maybe let's print here. Like, because this run almost immediately, so there is something fishy going on here. Println I would bet that I have something not correctly initialized. Finding max geodes for and minutes is minutes, and that's it. And here we just say state, just debug print and make it derive debug. Run this thing. We are starting with 1 OR, but then we are incrementing the minutes and the OR is not incrementing. So yeah, that's a problem. So when we do the tick, where is the tick? Here. No, we don't. We don't start with 1 OR. We start with 0 OR, but with 1 OR robots. That was our mistake. Robots is 1. And let's remove this, because now I think that will be very spammy. So run this. It's probably not going to finish in reasonable time. I should probably run this in release mode. Yeah. Probably like this. Okay. I do wonder like how many possibilities we are, like branches we are evaluating here. And yeah, if we could have some idea of how much time this may take. Maybe what we can do is to do maybe 10 minutes and see how much time it takes, and then increment go incrementing that. Let's do 10 minutes, and yeah, we are already like timing this. Well, that is 0 for both blueprints. That is very good. Let's increment this to 15. Well, okay, we have 1 geode on turn 15 for blueprint 1. And that already took 53 milliseconds. Let's see here, minute 15. Well, at the end, you should have clay collecting, obsidian collecting robots. Now we have a geode here at minute 18, and in minute 19 we crack 1. So this was yes, this was for blueprint 1. So I'm a bit suspicious of this printing 1 cracked geode for this. But this doesn't mean, it's not the same to be simulating for, like, if I only have 15 minutes, maybe I can crack 1 geode, but if I have to optimize for 24 minutes, it's another story. So this doesn't tell me the full story, so, but okay, we have 53 milliseconds. If we increment just 2 more minutes, 2 more levels on this tree, where do we go? We go to half a second already. This is gonna we can sort of, are these times sort of doubling? So let's go one more and see. Three seconds, so they are more than doubling. Beautiful, beautiful. This doesn't bode well for us. Let's go. I want to have like an idea of how much time I'm gonna be spending waiting for this. And of course, the real input are many of this. I guess I could run this each of these on a new. Wow, that jumped like tenfold. Damn it. That is beautiful. But also the numbers don't seem to be correct. Max geos for blueprint 1 is 15, but pretty sure that here, yeah, in 24 minutes we only cracked 12, so that's definitely not good. Are we not computing geo robots or cost? CDN cost. Yeah, those are the costs that we care about. And and here we have ore and clay. But yeah, this looks like we are at 19 and it's already taking. Oh no, it wasn't tenfold. It is. It was four times slower. So I guess we can crank it up to 20 and see, while we sort of think, why the hell are we getting more geodes than we should? So what are we doing with this return geodes? We are always finding the maximum between this and what we have here, and then we are just returning those. And since here we could take the 5 branches, or well, any of these branches, and then this one, which is unconditional, I guess we can do something more intelligent besides waiting always, because this means that for any branching that you have, you also have an infinite, not infinite, but a long list of waits until 24 minutes, which is never a good strategy, I guess. Like if on the given turn you can make every possible robot, for instance, you should not wait. You should make one. It's never a good strategy to wait in that case, I guess. Yeah, I don't know how to express that. 55 seconds it took for 20 minutes, and 21 geodes for blueprint 1. That doesn't make sense. How does it get such high numbers? Like, what are the costs here? The costs are 7 obsidian for geode robots, 2 ore. Oh, I'm not consuming. Yeah, I'm not consuming what the robots cost. That's an error in logic. Okay, so we have to increment the robot count, but we have to decrement the ore, like the resources that this is consuming. So, or we will decrement it by the blueprint or robot or cost. And we're gonna do something similar for the clay. except here it's going to be the clay robots or cost. And of course, this already starts to look like a pattern. Instead of asking if you can construct them and then construct it, and I guess another approach could be, hey, state, try to construct this, and yeah, and if you could construct it, then make a tick, and if you can't, well, don't. But anyway, that's, again, I don't want to think about the sign too much. So here we have Obsidian or cost, but we also will have, and of course I am realizing that I'm writing this wrong. We have to subtract this from what we have. So it's not just this, the or cost, but it's state or minus this. And we are surely gonna do the same here, and here and here for the clay. And commas are missing, yes. Okay, and then for the geode case, we need geode robots or cost, and the Obsidian, this state Obsidian minus the geode robots Obsidian cost. And I hope this should make our possibilities much shorter. Like like this should reduce the amount of branching, I think, because now we are actually reducing our resources. So let's see how, I think we have this in 20, right? Yeah. Before, with that bug, it took 55 seconds. Let's see how long it takes now. Oh, nice. 1 to 6 milliseconds, but neither produce a geode, and that seems like a bug also, because now we are simulating 20 minutes, and by minute 20 we already have 2 geodes. We should be able to have 2 geodes. So if we simulate up to 24, now does it finish? Well, yeah, and it prints something, 4. It's not the correct number, but it did something. And the blueprint 2 is taking way longer. So I guess, yeah, and that printed 3. But 14 seconds is a more reasonable time, and we can simulate all minutes. So I probably made some other stupid bug. So what are the numbers that we have? 4 and 3. We never have, I think, geode. We have 3 open geodes here, but we have 4. Then we've jumped to 5 open geodes, and then to 7, and then 9, in the best possible strategy. We never have 4, so it's interesting that we didn't get that strategy. So is there some stupid bug here? Our robots, we are decrementing the ore robot cost. Then here we are also decrementing the ore clay robot cost. Then we have this 2 ore and obsidian, yes. Here we have these 2 ore and clay costs. Yeah. Yeah. Beautiful. Where are we missing this? Then we take the maximum. This is always the same. Yeah, we're doing new states with this. And tick should be incrementing this by the amount of robots, geodes, obsidian, clay, and ore. Great. And copying everything else. D4 resources, yes. Yeah. That's the new state for the next turn. Okay, let's do only one of these. So we're gonna do blueprints. Let's get only the first one, like this. Right, and let's simulate a couple of turns, not 24. Let's do, I don't know, 4. Yeah, just to try to spot errors, like stupid errors in logic. So we are gonna do finding geos for these states some minutes. Okay, and I want to like indent this by the amount of minutes, so we have like a sort of a recursion tree printed. So how do we do that? I guess we can say iter repeats endlessly repeat. I don't want to endlessly repeat, but there's probably something that does no, I don't want this. Well, I guess I can repeat endlessly and then take something. Like repeat just this and take minutes of this, and then collect it into a string, I guess. Let's indent the string be this thing. I guess you want to have a usize, most likely, yes. And here just print the indent. Let's see. Look at that. Okay. We have 2 ores. Clay 0 in 2 minutes. Yes. So at the start of this would be the 3rd minute. We have 2 ores. Is that correct? I wonder, is this correct? Yes. And we should here yes, we do have the state where a clay robot was created under this. And no more ore remains, and we have the state where we waited. And then we have this another state where we created a clay robot. So yeah, this is also an interesting, another interesting case. Is like when, like if you can create a clay robot now, like you have the resources, well, you can simulate the possibility of creating that. But if you wait, then on that branch, it doesn't make sense to create, like if you have waited, then it doesn't make sense to create a clay robot in the next turn, like it happened. Wait, here we have, yeah, 0 clay robots, like it happened here, because like you could have made it the previous turn, and it doesn't make sense to do this. So that's also another way of pruning this tree. So far up to here, I don't see anything weird. Like it's pretty straightforward. I wonder if I made a very stupid mistake, like before. Can make obsidian robots. Can make geode robots. We are always calling this thing new state. We are always doing this. And like if any of these possibilities gave you a bigger answer than just waiting, then yeah, this is not going to, this will give you the maximum of those. So this seems weird. This seems weird. Next geodes. We observed that when we got to, I don't know, like let's see where we create the first, or where we crack the first geode. Yes, here you have one open geode. This is after minute 19, or on minute 19, like after that, we get that. And we start minute 20, we should start some minute 20. The thing is that if I print all of those, it's gonna be a lot of noise. So yeah, we're gonna go up to 20, and this is going to create lots of printing, right? Yeah, too much noise. Let's only print then when we are on minute 20, and I guess we don't need the intent then. Bye. Look at that. There are so many possibilities. I probably want to do something like count how many end possibilities we are doing, to have an idea of when we start to prune the tree. I have an idea of what we're doing. So okay, this is not great. Too much printing. So let's not print. And if I remember correctly, this was given 0 when it shouldn't, right? Yes. I wonder if I could, just as we are doing max geodes, like print the maximum of every resource, but we are not optimizing for maximum of every resource. Yeah. Okay. Let's keep this printing that we were doing, but let's go up to 5 and see. This is gonna branch a bit more than before. And we can see, so we have 2 possibilities for minute 3. Yeah. Let's make this a bit less noisy, I think. Just print the minutes and then the states. So yeah, we have 2 possibilities for minute 3, as we saw before. Then here we collect 2 more ore, minutes 4 and 5, and we just have 1 clay robot. And we should, how was the cost? Yeah, the ore robot cost 4 ore. So on minute 5, I think here, yeah, we should have a state that has 2 ore robots. Yes, this one. So this seems correct to me. At least 2. Yeah, up to ore and clay. I mean, it does seem sort of correct. Clay robots 1. Wait, shouldn't I see a state with 2 clay robots? I should, right? Here is the first time in minute 3. Like in minute 5, if we keep collecting with the first ore robot that we get, minute 5 we should be able to have yeah, have collected 4 ores, so some of the this seems weird. So here we created a clay robot. This is the beginning of the third, well, the minute 3, but this is since we starting at 0, I think I got a bit confused. This is a bit confusing by starting on 0. Because we should let's make things better for myself and start at minute 1. Like things better for my human brain, I think. And here we just ask greater than. Right? Something like that. Does it make sense? It should print the same, but yeah. Starting at 1. So on the first minute we start with this. The third minute we should start, yeah, we have 2 OR already collected, that's fine. Then the 4th minute, we consume those 2 ORs, but we have created a clay robot. But we shouldn't do that. Yeah, no, yeah, that's the error. We should keep the production of that OR. That's a bug. Yes, that's what we're undoing. Like here we are overriding. Yes, this new state. So what do we want to do? We want to make the new state, and then after that decrement. Does that make sense? Will it make sense to maybe do this in a more mutable way? I'm not sure. Yeah, let's say, if we say something like this, let's mutable new state be this, and then we can do something like new state dot or robots, we're gonna increment these, a new state, or we're gonna subtract the blueprint cost. Like we could do this also with the current state, and then say, hey, do a tick on this. No, but we, like the correct thing would be do this, then the tick, like decrement this, then the tick, and then increment the robot count, because if we increment the robot count before and then we tick, we're gonna be producing more than we should. But I think this is equivalent to that. Yeah. Yes, and let's run with this. I know that this is, oh no, we should do this with clay robot 2. Like we should do it with everyone. But let's start with this. Let's continue with this. So we're gonna do this. We are gonna, well, do something like this. State or, okay, clay robots. We're gonna increment or we're gonna decrement by the cost. And it should be mutable. Yes. Okay, let's run this with 5 turns. And now, when we produce the clay robot, we also have 1 OR. So then we will have 2 clay robots here. Yes, that does make sense. Good. Good. Let's do then the same thing for the other robot construction logic. Okay, we have a new state here. Here we have 2 different costs. So let's do new state dot blah blah. Put the semicolon here. Put the, well, am I doing this correctly? I don't know. Let's sort of looks like it. Yes. And let's do the same thing here. New state dot blah 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 semicolon. This should be operator equals. Look at that, multi-cursor editing. Okay, and now let's not print, and let's go up to 24 and run. And this will now be branching much more than before. So maybe we again fell into lots and lots of recursion. Let's check then. By minutes 19, we crack our first geode, right? Yes. So let's maybe not do all of that. If we do a much smaller number, how is the recursion going for this? Yeah, not 1 millisecond, so this is fine. Let's go up to 20 and see. Okay, 200 milliseconds, not too bad. And yes, no, we have after 20 minutes, yes, we have 2 open geodes. That's awesome. And if we say up to 19, then we'll have 1. And if we say up to 18, I think we should have 0. Although I'm not really sure, because as I said, maybe there's another strategy that optimizes, but no, it seems we get 0. Like it makes sense that the best strategy is always try to crank up geode cracking robots as fast as possible. So you start cracking geodes and accumulate more. So okay, that's pretty good. And 20 didn't take that long to run. Let's go to 21 and see, just to have an idea of how much. 21 is already pushing to 1 second. So if we go to 22, it's probably going to take, well, I want to see how much it's multiplying. 3 seconds. So it's like multiplying by 3, more or less. So if we go one more branch, one more level, we're probably going to be in 9 seconds. And if we go one more, it's like 27 or half a minute, give or take. So okay, and let's also run this for both blueprints to have like an actual answer. This is 22 seconds, and yeah, the second blueprint is taking way longer than the first one. There is something about that, about those costs, that makes it. And the second one is also like each geode cracking robot costs more obsidian, but it gives a better, like according to this, it gives a higher number of geodes cracked. So that's interesting, because it's each ore robot costs less, but the clay roads cost more, so I guess it can pump more ore robots first and then clay robots and be more efficient generating clay. I don't know what why it's so much better. Oh, I guess it's, yeah, also the obsidian robots cost much less clay, so that could also be like the reason why it manages to get more. So okay, we were how many minutes were we simulating? 22, and damn, it took 60 seconds already. Yeah, but let's see, 5, yeah, after 22 minutes we have 5 open geodes for this one, and for blueprint 2 we have 6. That seems very promising, and I guess if I leave it running, it will take, I don't know, 3 times more, then 3 times more, like that would be 3 minutes, then like 9 or 10 minutes, something like that. It's how long it would probably take to give the answer for the sample problem. So if I put the real input, I would probably get an answer in, I don't know, an hour or more. I could probably try to parallelize this, but also if I run it without OBS recording, it does run faster. Like my computer is a bit slow. But I think we can probably think of some way of pruning this or making this run faster. So let's tune this number a bit lower to have something that runs on a reasonable time. Let's see, with 20. Yeah, 20 takes 4 seconds. That's great. What can we do? There are a couple of things that I think. Let's add this. The code is pretty horrible, but it's simple enough, I guess. I want to reduce the amount of unnecessary waiting strategies. And also, yeah, this is fine. There is one thing that I'm worried about, and I would like to try to like optimize in air quotes, which is to, like, if I were doing this on a more imperative way, like this is pretty, you could say, like functional code in the sense that each, like, nothing is mutated here, but I would probably use a more like global-ish variable for max geodes and only do the comparison of this maximum in here when we early return. So I guess I could maybe pass the max geodes as a mutable reference here. That's one possibility. Or keep the max geodes maybe in the blueprint, for instance, like say, okay, these are the max geodes that this blueprint produces in so many minutes, and update that. I will try to go with a mutable parameter though. So let's see if this thing takes a mute reference. I think it is this way how we write this, called max geodes, which is U32. Why do you complain? Oh, yeah, I'm forgetting syntax. This is the syntax. mute reference is the type. And it doesn't return anything. This is like an output parameter. So here we could say blah blah, we are going to return, and we say, well, if the state geodes is greater than max geodes, then max geodes equals state geodes, which is the same as doing the max thingy. No, geodes, let's not confuse what we are talking about. And of course we need dereferencing and dereferencing, sure. And here we just early return, great. And here we don't return anything. And here we just recur without, yeah, and we have to pass max geos to all of these calls. So this is this, and max geos like this, great. I think this, yeah, this results, I think, in simpler looking code. Although I'm not sure if Rust will complain about mutable borrows, like multiple mutable borrows for the same thing, which we're going to see. I think this should be fine, but let's see. It doesn't complain in this function, or it does it. Found integer. Mutually borrowing where? Oh, max shields. This goes away because now it is the mutable thing here. Yeah, it's not complaining. That's great. But it will complain when it's being called. So let's say, yeah, instead of saying max geodes like this, we'll say let's immutable max geodes start with 0 and pass it as a mute reference, max geodes. How about that? Okay, I don't expect this to be faster, but it's just a change that I wanted to make. I also don't expect it to be slower, but maybe it is slower. Look at that. Oh no, just 4 seconds. Okay, it doesn't make a difference, and it makes sense that it doesn't make a difference. Like it's just a comparison in any case, and I wouldn't be surprised if the compiler optimizes a lot of this away. But anyway, we now have this like as a mutable variable, which I think is simpler to understand. Fine. How can we prune this mess of a tree of recursion? Maybe another mutable variable that I could be passing is like the amount of calls that this gets, so we can evaluate how many states we are reaching. Yeah, how many like end states we are reaching. The answer is still the same, right? Yes. Oh, look at that. For both blueprints at turn 20, we have 2 geodes, but then blueprint 2 starts to go faster. That's interesting. What can we do? What can we do? Well, I guess one thing, I don't expect this to be too interesting, but if we can make all robots, let's say can make any robots if it can make ore robot and can make clay robot and can make obsidian robot and can make geode robot. So this is, in this turn, you could have chosen any robot to make, and you have the resources to make everything. Then it doesn't make sense to, in this case, I'm sure it doesn't make sense to wait. So I guess we can say if can make any robot, just return. Like an early return. I don't expect this to cut too much, especially, especially now that we are not running up to 24, because we just cracked, like we just made one obsidian geode cracking robot. So maybe this is not an interesting optimization, like, or pruning to do. What else can we do? What else? I'm also thinking like another way of approaching this. Hey, don't take more time to build something if you can. Like instead of, like, if I can make a, I don't know, a clay collecting robot now, but I don't do it and I wait, and then in the next turn I make it, like, it doesn't make any sense if I could have done it before. I guess one way of implementing that could be to have some sort of cache and remember states. Like, yeah, I have already been in this state, and if it is the same state and we have already computed, the max geodes for that, then we can only return, right? But is it the same state, or is it the same, like, robots but not resources? I don't know about that. I'm not sure, but maybe we can try a naive cache and see what happens. How would we do that? Well, we have the max geodes. This is our sort of output parameter. We can also have like a states cache, which could be a hash map of state to the max geodes. That state produced. That state produced. I don't know, how do we do that? How do we populate? We would only do this on the leaves. I don't know if that makes a lot of sense, but it doesn't. Also, if states repeat, which I would think they do, because there are so many. We are evaluating so many states. I would think that they probably repeat. It's like, okay, if you have already computed the max geodes for 1, then that's going to be the same when it repeats, right? I think so. But how would we write that? Well, I guess here at the end, we would have to like not avoid some of these early returns, but at the end we would have the max geodes variable written with the max geodes that were calculated on these branches. So in that case, yeah, we will know what that state will have, I think. Yeah, right, sort of like that. Although we also need to say, okay, that state at a given minute, I think. Yeah. Yeah, this makes sense. Okay. I think we can put the minutes into the state, but we can also get by not doing that, doing something like this for now. So hash map, import this. This is going to be a reference to a hash map. What don't you like? Straight has to. This is what I wanted. Yes. It's gonna need to be mutable. Yes. So let's see. If we say something like, hey, if state cache gets get the cache entry for this state and this minutes, right? Yeah. This is some oh, I think there's an entry API that would be better for this, but anyway, if this is some cached state, no, not cached state, cached geodes, then return cached geodes. Is this what I want? What are you complaining about? This method for mutable reference, the following bounds. Yeah, I guess we need to make the state be hashable and equal. That's fine. States also have hash and EQ, and I guess this also requires a partial EQ. Beautiful, beautiful. And expected reference, yes, sure, be a reference. Catch geodes, you can be this. Oh no, we are not doing that. In this case, if this is, yeah, no, if we have reached this, then it means Well, we have seen this state. If we have seen this state, then that's it. So can we ask like has key contains key? Yeah, it contains key. We have seen this. We just return. And state, what's your problem? Sure, do this. Very beautiful. Okay, if we have seen it, return. Great. Now we have to forward this in these calls. So let's maybe look for this. Pass the state cache. Beautiful. What don't you like? Repeat the thing. Okay. So we are reading from the cache, but we are not writing to the cache. Here we are writing this max geodes. When should we write those caches? I guess what are our returns? Only those two, and here we do this. So I don't know if I need to write to the cache in this case, which is the one that writes the max geodes, because basically this state we are not going to be evaluating it. Maybe I do, but this one, like we are not simulating that this minutes. But in here, I'm pretty sure that we do. So here we know, like if we reach here, we know that the cache doesn't have this. Or well, maybe now it does, that we have written so many things. I'm not sure. So we can say cache insert. The key is gonna be state and minutes. No, but we have already incremented minutes, right? Yeah, that's something that maybe we don't want to do. Maybe what we should be doing here is on all of these calls, just plus one here. And yeah. Okay. So for this state, the max geodes were this geodes. And here we do this. How about that? How about that? Find max geodes. Here we need to pass a new cache, so that will be hashmap new. And you don't like this because you need to be a mutable reference, of course. How about that? Does this make sense? I'm not sure. Don't even like. I wouldn't be surprised if this makes things way slower, because we are hashing so much now. And we have move out of, yeah, we have some problems also. But I want to simulate, okay, maybe 20 is fine. Let's run. Okay, cannot move out of state, which is behind the shared reference. Move across. Oh, it's not copy. Okay, we can copy the state, or we can have a reference to it, right? Because we are not mutating these states at any point. So why don't we just have references to state? Yeah, why not? I don't know. Let's go with that. Yeah, it should make also the cache a bit more lightweight, I think. Let's run. Let's see. Oof, lifetime problems, yay. Lifetime may not live enough. Sure. Yeah, because we are putting it here. Okay, let's make it copy then, and not worry about that. Yes, that's state. Let's also you do hash and blah blah. Let's make it copy, and I think this also needs clone. Look at those, all those traits. Okay, so I mean, we were running in 4 seconds. Now it's 3. It is something. It's not great, but it is something. Let's go to 21 and see how much, like how fast this increases. It doesn't look very awesome. 8 seconds. Yeah, and we saw that for 22 it was taking like a minute, I think, before. Let's see. So it went from 3 to 8. Now 18 seconds. So it's not 3 times slower. It's 2 and something times. So from 18 for 23 minutes it will be like 40 seconds, say. And to compute the 24 minutes it will take like, I don't know, 90 or 100 seconds, which is not that terrible. I think I can probably live with that. Before, I think we estimated that it will take like 10 minutes. One thing that I was thinking of, but I don't know how to implement it very efficiently, or like how. Here we are saving state with given minutes, but if we instead would say something, hey, this state produced this amount of geos, like I have seen this state producing this amount of geos in this amount of minutes, and we could look for that state on the hash, and we see the same state, but our current minutes is larger, then we can also early return, because it's like, okay, we reached the same state, but after more time. So I think that sort of makes sense. And maybe it's not much more complicated. Let's see. We will hash from state to a tuple with minutes and geodes, which is beautiful to have as types like this. I should probably use some opaque type or something, but let's not think about that. Okay, we have a state. Let's look for this state. But it's not just contains key, because if our current minutes is less than that state, we should continue. We should continue in that case. So let's do get and if let minutes, cached minutes, and cached max geodes, right? Something like that. This is sum. I don't know why it's not complaining. Like it is complaining, but I don't know where. Oh, on the insert, okay. Yeah, since it is complaining about this before, it doesn't tell me about these unused variables. So what do we want to say here? Well, if the cached minutes, if our minutes is greater than this cached minutes, then we return, I think, right? Dereference this thing. We have seen this same state, but this should be if it is greater or equal, right? Yeah. Same state, but on but with more minutes to spare. Yes, we have seen the state with more minutes to spare. Now we know that that state was either not in the cache or in the cache, but for a larger min. So we are either on a state that we haven't never seen before, or on a state that we have seen before, but at the previous, yeah, with more minutes to spare, like at the previous minutes. So we want to insert in this case. We want to insert. So insert onto this state. We are gonna put minutes. Yeah, the current minutes and this. I don't know how much sense this makes, but let's run. Cached max geodes, we are not using that. And this is what before took how much? 18 seconds to, and now it took 11 seconds. That's nice. That's a nice improvement. We are not using this cached max. We don't need to actually put this cached max geodes now that I think about it. Yeah, we don't need this. Yeah. I don't know why we can probably remove this, but okay. And we are simulating up to 22. Let's simulate up to 24. This will take a minute or so, but I want to see the actual answer. So wait, so after 22 minutes. Yes, it is 5 on this. That's great, and 6 on the other. All right, let's go full 24 and see if we get the correct answer for the sample, which should be 33. Okay, we got the correct answer for blueprint 1, which is 9, and we should get 12 for blueprint 2, but for some reason blueprint 2 takes way longer. This hashing thing, I'm not a fan of having this hash maps. Like, it's not like we are pruning the tree, it's just we are deduplicating some branches. You can probably make the logic of waiting way better, I think. Of not waiting, way better. But let's see. Yeah, because we got 33. That's great, and it took 70 seconds. So if this is any hint of how much it's going to take for the real input, real input is 30 blueprints, and this was like a minute, let's say, for 2, then it's going to take 15 minutes to make the 30, I think. Unless there are some blueprints that take way longer. I don't know. Because the real input has some very large costs for Obsidian, but also some pretty small ones too, like 8 or 7 even. So I don't know. Maybe let's put this real input in here and start running and see what happens. So we run. Oh, look at that. The first 2 ones were pretty fast. Okay, I don't think I will wait recording for this to finish, but I would probably leave this running and do something else and see how it went. So I guess I will stop recording so my computer also runs faster. See you later. Bye bye. Right, and we are back after this finished running, and it actually didn't take as long as I thought it would. I thought it would take like 15 minutes, but it took like 4 minutes and something. So that's good. And we have an answer. And I noticed that while this was running, some of the blueprints were computed pretty fast and some took much longer. And this one, for instance, 26, I think it was the longest it took to compute. And it's the maximum number of geodes. Let's take a look at it and see. Yes, this blueprint 26. Okay, every robot costs 2 ore, which is very nice. And this one the obsidian costs 7 clay only, so that's good also. And then the geode costs 14 obsidian, but it seems like being so cheap on ore is really helpful. Okay, but we have an answer. So let's try to submit this and see if this is correct. Let's go. Yes. Nice, very nice. This one was a very difficult part 1, and I really want to try to optimize that thing, but let's see part 2. Oh, now I'm already reading here 32 minutes. Damn! While you were choosing the best blueprint, the elephants found some food on their own, so you're not in as much of a hurry. You figure you probably have 32 minutes before the wind changes direction again and you'll need to get out of range of the erupting volcano. Unfortunately, one of the elephants ate most of your blueprint list. Wow! Now only the first 3 blueprints in your list are intact. Interesting, okay. In 32 minutes, the largest number of geodes blueprint 1 from the example above can open is 56. One way to achieve that is, well, and we have a printing of every possible minutes. I wonder if this is useful for me, like to print for a given minute. What is the best strategy? I don't know. Like, I wonder if there is a very different technique. Yeah, I guess what I'm doing is like a depth first search, because we are recurring and going to the end of each possibility on the tree. But another possibility would be to do a breadth first search, which would be, I don't know if that's like that's easy to implement with recursion, or we would need some data structure to like reify the stack call. But I don't know if this printout of the best moves is really useful, or if it hints at another possible implementation. However, Blueprint 2 from the example level is still better. Using it, the largest number of geos you could open in 32 minutes is 62. You no longer have enough blueprints to worry about quality levels. Instead, for each of the first 3 blueprints, determine the largest number of geos you could open, then multiply these 3 values together. Okay. Just multiplying those 3 together. So still we have to compute the full thing, but only for 3 of the blueprints. That's good. It's kind of good, actually. I don't know if the same approach, brute forcing approach that I have now, will be able to go up to 32. No, it won't. Like, we are in 24, and it's taking like, say, 30 seconds for a blueprint. Yeah, no, this is not going to work. How do you get if? Yeah, okay. So we have to compute this. This will need some actual optimization. Okay. So how do we do that? First, let's add what we have here, as it is a valid solution for part 1. I would like to sketch out maybe a solution for part 2 that maybe continue at another time. So let's see. Now we have to count to a different number, so this way of doing things is not going to work for me. So quality levels, quality level. Okay. Yeah, let's do let's first do something simple. Well, maybe first go back to the sample solution and invert. I think I want to invert this. Instead of passing minutes, I'm going to pass remaining minutes. And we're gonna say, okay, if remaining minutes is 0, there's nothing else to do. That's our termination condition. So we're gonna do the same there. Now, remaining minutes here, we have to use invert the logic here. So if the remaining minutes is less, before we were doing greater or equals, I think we have to say less or equals. So this current have the same state, but with more remaining minutes. So it doesn't make sense to evaluate this okay, something like that. And then instead of passing remaining minutes plus 1, oh, what the hell did I touch? I closed the window. I have a shortcut that is very weird, and sometimes I confuse and touch it without meaning to do so. Okay, this thing, instead of doing plus 1, we're gonna do, of course, minus 1. Right? Yes. Yeah. Okay. And now when calling this quality level, we are gonna start, I think, in 24. So yeah, if we start at 1, we're gonna compute, yeah, we're gonna simulate 1 turn, and then it will reach 0, and that's it. So here we pass 24. We what else? Well, we can make a function here, fn instead of quality level, we can say also like find max geodes in some minutes. And we are gonna do this basically. Yeah, just extract this thing. Here return max geodes. Here we're gonna say self find. Of course, this should take a reference to self. Max geodes in 24 minutes. This will return the number of geodes. That's great. And we are gonna pass this max geodes for blueprint in minutes. Great. So yeah, those were the quality levels. And now we will have total quality level. Say let first blueprints max geodes, and we have just to multiply them or add them. If you multiply these three numbers together, okay. Max geodes products, very long varname. Let's say blueprints, we're gonna take the first three, so something like this. I don't know if we have like slice, splice, or take, or first. Yeah, no, let's just use slice syntax. We're gonna iterate them. We're gonna map to blueprint print, and we're gonna do blueprint find max geodes in 32 minutes, and then we are gonna do the product of this. And I guess this should go fine in a U32, I think. Great. Let's also print this. So this is a sketch for what we want to do, but this is gonna take a lot of time to compute. So we can say something like, yeah, our current solution for this is not great. For part 2, I want to see if we can say, yeah, if remaining minutes is 32. So in that case, just return, I don't know, a number 5. So 5 times 5 times 5 should be 125, and that's, why do you complain about this? Oh no, it's not return 5, it is say max geodes equal 5. And return. Great. Let's put this here. Let's say to do remove. So okay, if I remember correctly, computing this for blueprint for the 24 minutes, max geodes for blueprint 1 in 24 minutes is 9. Yeah, great. The other one took like a whole minute to complete, but then we start to get into the 32 minutes realm, and that's gonna never finish. So I sort of want to see, yeah, no, let's kill this. Let's just do here, let's not evaluate the first part, let's just say 0, 0, so that's an empty slice. This should, well, it's blew up. Maybe some was, no. Range and index 3 out of range for slice of length 2. Oh, I didn't realize that. Yeah, this thing is Okay, we can of course fix this by saying iter take 3. Simpler, much simpler. We should see like 0 and 25. Ah, yeah, because we are we're making a product, but it is doing 5 times 5 only. Real input should be this. Let's go here. Should be this, and if we run with this, yeah, 125. Okay, so I think this sketch does make sense. Let's remove this, and let's remove this. Yeah. So this should be a correct solution, but I don't know how long it will take to finish. So we probably want to investigate, well, more efficient ways to do this. Maybe doing a breadth first search would be better. Although I cannot think of a simpler way of doing this, like off the top of my head. I should probably read some about, like, with at least the Wikipedia article on breadth first search, because I don't even remember if I ever implemented something like that. But I think what I would like to do the most is probably try to prune this gigantic tree a little bit. Oh, by the way, one thing that we can do for sure would be to, okay, actually I sort of want this. I want this idea. I still want it, I think. Actually, let's maybe ignore the part 2 for now. I can do this and say, hey, blah 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 is 0 for now. Let's put it up here. What was I saying that I wanted to do? Oh yeah, one thing that I would like to do is to print how many elements are on that cache after doing the thing. So yeah, because that would give us the number of unique states that we have seen, yeah, on each minute. It's not how many nodes we have visited, because we were already doing some optimization of not putting things on the cache when we have seen it with more time remaining, but at least to have an idea of how big the cache is. So again, let's do blueprints only the first one, because that's faster. In 20 minutes is this max geodes. Cache size equals well, here I need a reference to this thing, so let's say let's state cache be this, and let it be immutable. So state cache, great, and here let's say state cache length. Run this. So this should compute. Takes 3 seconds for, no, but it says says 2. No, that's not right. Where did I mess up? I did change a couple of things here, right? Yeah, the +1. I don't know why this thing decided that when doing a +1 instead of a -1, like the -1 for some reason puts things into different lines, while the +1 was okay being in one line, but I don't know, formatter logic. We're not getting the same answer. Why not? And why only 2? Yeah, I did something pretty wrong, but we are already having like 2 million items on that cache, which is a lot of hashing to do, which is quite a bit of hashing. I could probably optimize that, the hashing part, quite a bit too, I think. But anyway, we should be getting a different answer here, which we are not. In 24 minutes, max geodes is 2, which is not correct. It should be 9, was it? I think it was 9. And the second blueprint was 2. Yeah. Squarity level should be this. So I've already screwed up this. Max geodes, stable cache, minutes. Yeah. Okay. So we have the remaining minutes. I guess this logic is could probably be wrong, because for all the other stuff we are just passing remaining minutes -1, which should be fine. Is there a possibility that we are doing an underflow and in release mode we are screwing this up? I don't know. But we have less remaining minutes, or the same amount of remaining minutes than the one we cached. This, I think, it makes sense. It does make sense. Max geodes. Huh. What is happening here? Like, what did I change? We were starting at 1 and we were doing this +24. Oh no, this also changed to multiple lines because I renamed minutes to remaining minutes. Okay, makes more sense. Yeah, we're putting this into here. And here remaining minutes. Yeah. What the hell is going on? I guess we could also like pass a max minutes thing and not change that, and then have a mutable, like change the minutes and count up to that. But I mean, the logic should be the same, I think. Remaining minutes cached. This is the cached remaining minutes, yeah. I made some stupid error here. We are passing 24. Where? Here. Minutes, yeah. Just, yeah, like the starting minutes. We know that at minute 20, I think we had like 1 geode or 2. After minute 20, we should have 2 geodes, but I think now we have none. So we screwed up there somewhat. If we go to 22, what happens? Still 0. And I guess in 23 we're gonna have our first geode, and in 22 we have yeah, there we have 1 geode. 24 we know it's 2. 25, let's see, does it jump up to 3 open geodes, and then you have a new geode cracking code? No, it jumps to 4. What the hell? What the hell? This doesn't look like what we were doing. So weird. I didn't change any of the other logic. Let's do something simpler. Let's do 10, but run it without the release flag to see if we are having some sort of, underflow, overflow, something like that. No, that's not the case. Okay. Then what is the case? We can probably pass. First, we were passing 1 here and cutting the recursion when it was yeah, when it reached 24. Remaining minutes is this makes total sense to me, and I think this too. But I did screw up something in this logic. Many minutes. We don't have any other mutable thing here. So it used to just start at 1. Yeah. Huh. Damn it, I don't understand what's going wrong. Let's stash this change. And if we run now, we have all the blueprints. So let's run for the first one. This should run to 24. We have all of this. No, wait. Oh, I'm an idiot. Did I have the did I have the actual input instead of the sample one? I think I am an idiot. Let's do this, let's do a stash, pop stash of TMP. Why do you have conflicts? That doesn't make any sense. Just accept all incoming. I don't know if I screwed something up. We have the remaining minutes here. Yeah, sure. And we have that. Okay, let's run now. This was taking like 10 seconds or something. Oh no, we are doing 25. No way we're doing 25. It should be 24. Actually, let's run to 20 and do a smoke test of this. Yeah, we do have those two at 20, 24. And we have 200,000 entries on the cache. Not that many. Now we should have was this taking so long before? Like, it shouldn't be taking more, but for some reason this is taking more, I think, than doing the reverse, right? Yeah, it did compute the geodes, the 9 geodes, and it's 5 million entries, but it did take, oops, it did take, where, oh, I was confusing the shortcuts again. Did take 32 seconds, which I think is much more than it was taking before. So what if we quickly change this? Yeah, instead of remaining minutes, let's go back to minutes. Let's go back to greater or equal. Let's go back to say more than 24. Let's go back to say +1 here. Right, this should be, I think, the same logic. Should work the same as before. But let's run it now. Am I running? Oh, I was running in debug mode. I did run that in debug mode, I think. Man, I am just making stupid mistakes. I should take a break. So okay, remaining blah blah. Let's go to 24 again. Yes. Running release, please. You can probably tell the difference between release and debug. It's not such a big difference, 32 seconds versus 9 seconds. Like, it is large, but not an order of magnitude. But okay, yeah, we do have, I think, an acceptable solution for part 1. We can remove this. And we can leave the sketched out solution yeah, I mean, yeah, let's leave this Oops, let's leave, what is the shortcut again? This one. $32, okay. Yeah, also 32 is a power of 2. I haven't considered that. Interesting. Like it's making you think of how many possibilities there are. Yeah, discard these changes, sure. And yeah. Let's have this and commit it as a naive solution for day 19. Part 1 runs in about 4 minutes, but I don't know how much time it'll take to run part 2. This needs some called tree pruning. All right. Damn. Okay, we do have that. Let's go to what I had before here of only computing this, which is with what I want to try to optimize stuff. So we do have, we did have this check, which is if you can make anything, then don't do the waiting. Don't do this. So I guess we can say like the negation of this, what is like cannot make any roads, can make something, but yeah. So we can put this inside of here, and in any case we put the thing in the cache. So as this cuts something, we had 5 million elements on the cache. If we run this now, what do we get? Oh, did I screw this up again? Ah, yeah, yes. Okay. I have this input. Let's go back to this. 9 seconds, so I think it's not, well, it did cut something. It did cut something. And 1 second, so it's not insignificant, but it's not great either. So I think it's not just this what I want to say. For example, let's say if we can make like if we have the resources so that we can make an OR robot and we can make clay robots, we have the resources to make either one of them, and we don't have any clay robots, so state clay robots is 0, then we shouldn't wait. That's one possibility where we shouldn't wait, right? I think so. So let's call this I know that I shouldn't be using negative booleans, but I mean, that's how I thought about it. If this is should wait is the negation of this, which is cannot make or robot or cannot make clay robot, or it has clay robot, which is not the way I'm thinking. So shouldn't wait is the same as yeah, let's just say shouldn't wait or don't wait. We don't like this because probably capitalization, yeah, no, or spell checking, but I don't care. Okay, so we have that. That is a case where we can say don't wait, but then we are going to say if not, don't wait, which is like ugly. So does this make sense? I mean, I think that this makes sense is that, okay, if you could have made both and you still don't have clay robots, because if you have clay robots it's another thing, like maybe you're also waiting for clay to make an obsidian robot. Yeah, we can think about the Boolean name later, but what I want to say is it's either gonna be this or same thing, like can make these two and can make obsidian robots and doesn't have obsidian robots is 0, or the final case, which is this of being able to make anything. Beautiful, beautiful Boolean. And beautiful double negation here. If don't wait. Well, not entirely sure about this logic, but in my head it does make sense, and it should prune a bit more than we had before. So let's run and see. But maybe it's a lot of evaluation of conditions for not much gain. Yeah, it's not an amazing gain. A couple of seconds. It's not amazing. It's like we are cutting some unnecessary weights. But not too many. What else can we do? Okay, I think I have to think a bit more about this, so I will come to this later. I'm tempted to leave the solution that we had, like we have committed, leave it running and see if I get an answer for part 2. It's gonna be terribly inefficient, but maybe I can get an answer. So I will do that off screen. So anyway, that's the end of the video. So if you have been, thanks for watching. Goodbye. Well, quick update about this experiment. I left the code running, the solution that we had, and it couldn't complete for part 2. It got killed by the out-of-memory killer. You can see on these graphs I have here, like the memory started creeping up, and then at some point it started using swap. and then it got killed. And of course, this is not happening because of recursion size. The only thing that we are allocating dynamically on the heap is the cache, the state cache. And we can see that already for 24 minutes, some entries on the cache, like this one, which is the one that computes, like calculates the most geodes or cracks the most geodes, already has 55 million entries on that cache. 55 million is not too much. It's okay, 55 megabytes, but we have to see how many, how much space does that actually take on the hash, like how much each entry on the hash takes. And there is one trivial optimization that we can do, which is to not insert the max geodes on the hash, because we are not using that for anything. But I want to see something, which is the size of the state. Let's do here in main println mem size of state. Let's see if this is a big state or small state, like some libertarians want. Let's run like this. Could not compile. Yeah, don't pay attention to that. Oh, come on. Just print this. 32 bytes. That is quite a bit for the state. Because we have, well, we do have 8 variables of 4 bytes each. So that's exactly 32. Makes some sense. I wonder if we could make these things just bytes, like U8, because we never have so much stuff. This should make the entries on the cache significantly shorter. So here we are comparing things to the max geodes. That is, I guess, okay. The blueprint thing also needs to be U8s. So all of this, let's also make you U8s. Okay. So find max geodes. Minutes, I think, can also be, yeah, why not? Since we are also going to store these things on the cache. I don't know if the max geodes, because does that make sense to be UAs? I don't know if in cases where we are computing more, like this will be a bigger number. Maybe it will. So, okay, let's make this thing be U32. So this is as U32. Do the multiplication. Here the minutes is U8. Okay, so in here, let's receive the remaining minutes as U8. This doesn't need to be greater than that. here we're going to store the minutes as U8, and actually we're not going to store the max geodes. We don't need that number here. So here just have cached minutes, great. And here let's compare them as U32. If it's greater, well, just insert it as U32. That's gonna be fine. And here just insert the max minutes into the cache. Okay, that seems better. Let's run now. Okay, so the size is now 8 bytes, so that is 2 words on a 64. No, it's actually 1 word on a 64-bit machine. Exactly the word size. So that's pretty good, I think, for the cache. Like it would make things I think quite smaller on memory usage. So yeah, maybe I can leave this running again and see if it doesn't get killed by the killer. Anyway, yeah, I'll cut the video now. See you later. Bye bye. Hey, last update. So good news. I got this to actually run in a decent amount of time and got the answer. So you can see if I run this thing now, it computes the part 1 for 24 seconds pretty fast, and then it computes the answer for part 2 for the 32 minutes for the first 3 blueprints in a couple of seconds, in, well, 6 seconds now that I am recording, but this was 3 seconds when not recording because OBS takes some resources from my computer, and this is the correct answer and I have submitted it. So that's really nice. I wasn't thinking, like I did not think that I could have this thing running on a decent amount of time. Like the first time I submitted it, I left it running for, I don't know, it printed like 400 and something seconds, which is, I don't know, over 5 minutes or much more actually. But anyway, I want to show you what are the the simple optimizations that I made to trim the tree of possibilities, and there are actually 2 or actually 3 things that I think are kind of interesting. So let me remember, I'm checking the difference here. So, yeah. By the way, I had to change. Oh, at some point I made the state have everything be bytes. Yeah, I think I recorded that. So to make the state cache a little bit smaller and try to be able to not get killed by the out of memory killer. But then at some point making calculations with bytes, I got into overflows, so I went back to 32-bit numbers. But yeah, the first sort of interesting optimization that I made for pruning this tree is this idea. So imagine that oh, by the way, I also turn around the conditions here. I'm asking first if I can make geode robots, then obsidian, then clay, and then ore robots. So to have them like in order of importance. And whenever I can make a geode robot, that's it. I early return from here and I don't evaluate other possibilities, because I don't know if this is like 100% correct, but I like the solutions at least are correct, the ones that I got. But I think it's kind of intuitively is, because you want to optimize the number of geode cracking robots that you're making, and if you can maybe make another robot in this turn, it's like, okay, maybe it might help you to at some point in the future produce more geode robots more quickly, like, or maybe with one more robot of another kind, you can get to produce geode tracking robots like on each turn. But really, if that's not the case now, at some point you are going to miss a turn, but then at that point you are going to construct that other robot that helps you do that. So I don't know. I'm not 100% sure if this is correct, but I'm pretty sure that it makes a difference. But actually, we can check if it does. I know that the condition is hit, but I don't know if this affects the runtime. So we had 6 seconds before, yeah, 9 seconds. So it does affect it actually quite a bit, and it doesn't change the results at least for the blueprints and strategies that we have here. So yeah, that's a small tidbit. But the thing that I wanted to mention was something else. So we have these local variables where we check, like where we store if we can make a robot or not, a type of robot or not. Now imagine the case, like maybe the simplest case of making an OR robot. Like if this is true, it means that I can make an OR robot in this turn. So here we make it and we do the recursive, like we evaluate that branch of the tree. But we can also choose to wait and not create these robots and maybe create something else, or wait in order to be able to create another kind of robot. But if we choose to wait and evaluate that other tree, it doesn't make sense, like in the other branch, to make one of these on the next turn, because we just waited, like this is the else branch of constructing this robot. So it doesn't make sense to wait a turn to then create this thing again, this robot again. I don't know if this... Yeah, it's like you're taking one more turn to make the same thing. Why didn't you make it earlier? So that's kind of the idea. And so what I do is just simply forward these 3 can make OR robots, can make clay robots, can make obsidian robots, not for the geode ones, because as we just seen, when you can make a geode one, you don't evaluate the other things. So this is just, we are passing this just for the case where we are evaluating, okay, let's wait in this turn. When we are evaluating the waiting branch, we pass these arguments that basically mean, and we receive them here, right? Could make OR robot, could make clay robot. Like this basically means in the turn before, in the minute before, we could have made one of these, but we didn't. So in that case, we could make one before and we didn't. Well, we use this thing to ask here, when we can make an OR robot, we only make them if we can make them now, but not in the case that we could make it before and we didn't make it, because then like that's something that we decided that doesn't make sense. So, and we do the same for all the other, like all of their kinds of robots. And when we can make them and we decide to make them, in that case we pass false, false, false for each of these, because it's like, okay, it's a new branch, we created something new, we forget about, because it's no longer waiting turn. So that gets rid of lots of possibilities in the, like of lots of nodes in this search tree. So yeah, that's a pretty interesting one. Now that I explained it, I was wondering if it would also make sense to merge this. No, I think this is fine, like the way we are calling this here. So okay, that's a pretty good optimization, but the best optimization for trimming the tree, and I actually didn't think that this was going to make a huge difference, but it actually does. It makes a gigantic difference. If I Yes, it's this code. Let me comment this early return here and run the thing. So it basically takes way longer to run. Not so much for these 24 minutes cases, but for the 32 minutes, it's way longer. It's minutes. I don't know, 400 seconds, something like that. This is the thing that made the hugest difference. Or maybe it's not 400 seconds, but it's a lot. We can leave it running while I talk about this. So basically, this idea is affects the branches on the tree, where we have like only a few minutes remaining. And if you think about this tree of possibilities, the tree is not very tall. It's only 32 levels at most, like 32 minutes, but it's very wide. It's so wide that it's all of those wide possibilities of branching that takes so much time to compute. So if we can trim some of the last levels, that can make a huge difference, because as this thing is branching more and more, the last levels are the ones that occupy the majority of the nodes. So the idea is, okay, so if I have a few minutes left and I'm evaluating possibilities, I have to optimize at that last point. I really have to optimize the making of of geode cracking robots. Like, it doesn't make sense to do other things if I can make those. And maybe I have a couple of robots. Maybe I have one geode cracking robot, and I know already that the some other branch on the tree has marked the max geodes possible as, I don't know, imagine it has calculated 6 max geodes, and I have only 3 minutes left. There is no way that I can produce 6 geodes in those 3 minutes. So basically, I compute a very conservative upper bound for geodes. Let's see if this thing has finished running. Well, it's still computing. It has finished the first 2 blueprints for 32 minutes. Well, we can see then how much it took to run. So as I was saying, I'm computing a very conservative upper bound for the amount of geodes that I might be able to produce. Like, I won't be able to produce more than this. And it's basically how many geodes I have right now, plus the amount of geode robots that I have multiplied by the remaining minutes. So I know that these geode robots that I have right now will produce this amount of geodes in the remaining minutes. So this is for sure what I will produce. And then we have this speculation factor, or yes, we add this, which is what we could theoretically produce. And basically, if I have, and this is a comment that explains this, if I have n remaining minutes, we can at most produce n geode robots in these n minutes. So, of course, we cannot produce more than that, because we can produce 1 robot on each minute. And we probably won't produce n geode robots, but in the best case possible, we are producing n geode robots. And this will, these n geode robots will be able to crack. So the first robot that we produce, imagine that there are 5 remaining minutes. The first robot is going to be produced in this minute, and then it will crack 4 geodes. The next robot is going to crack 3 geodes in total, the next one 2, and the next one 1. So if I have if I can produce n geode robots, I can crack n minus 1 plus n minus 2 plus n minus 3 and so on, plus 1 geodes. And this is the same as the sum of the n minus 1 first integers, which has a formula and is n minus 1 plus n divided by 2. So that's basically what I'm adding here. And if this theoretical upper bound is less or equal to some max geodes that has been computed on some other branch, that's it. I don't need to keep evaluating this, so I save this in the cache and I early return. And this thing is what makes the difference, as we have seen, between 165 seconds to compute. So okay, in this case was not the 400 seconds. I don't remember which case that was, but it makes the difference between this number and the 6 seconds that we saw when we have this code and we do this early termination, because we know that we are no longer going to be able to cross this upper we know that we won't be better than the max geodes that some other branch that has had this max geodes. Like, we have no possibility, then we terminate early, and this, as we have seen, computes the thing in like 6 seconds, which is much faster. We can see it doing now. Yeah, very nice. And yeah, those are the two interesting, I think, call tree pruning techniques. But there is one more thing that I got really surprised by, which is considering the cache of this. We are caching the different states, and remember that this cache is using a hash map, so it's doing a lot of hashing. So look what happens when we just remove this cache and say, okay, let's not do this optimization of checking if we have seen a state and returning in that case. So let's remove all caching. And so there's going to be some calls here that we can remove, and remove. All these cache inserts we can also remove. It makes the code much simpler. So this was a very important optimization at the beginning, because we had such an enormous tree that without this optimization, things took forever to run. But now that we are pruning the tree a bit better, look what happens. Like, I mean, by the tone of my voice, you can probably infer that it's not going to make much of a difference. Like this, maybe the cache now is not saving us so much time, but actually, well, that's a warning. Actually, now it runs in less than a second, like 700 milliseconds. The cache was making things slower because of all the hashing. Like we remove the cache and now things are faster. And I love this example because this is actually not something so uncommon in programming. Sometimes you think you're making things better with cache, and maybe that is true. You always have to measure, but maybe that is true for some time, but then maybe you optimize something else, and then the cache no longer makes sense, and it's like may actually be making things slower. So that's really nice. And when I run this without recording, it's like half a second. So it cracks me up that now without the hash, like the hash was the cache, sorry, was making things work. Well, the cache and the hash, that's what's happening inside there. So yeah, I'm very, very happy with this result. Now things running in under a second. I guess I can also get rid of the printing. And yeah, I don't think I will be doing much optimization work after this. Maybe I could try to parallelize this last part, the thing that was computing, like the 32 minutes simulation, like the part 2. Maybe we are using, like we are taking the first 3 blueprints. Maybe I can run this in 3 different threads, because these are different, like independent computations. So that could speed things up a little bit. But other than this, I spent a little bit of time thinking of ways, in other ways that we could trim the call tree, but I don't know, I couldn't think of anything else, at least with this shape of things that we have now, because most of these ideas came by looking at, okay, what do we have? We have these booleans, we have these things, and under which conditions I could like maybe not call recursively to this function. But I haven't found other opportunities. Okay, so yeah, look at this, under 700 milliseconds. That's great. So maybe we can add all of these changes, take a last look at the code, and maybe make things a bit nicer. But yeah, this is already in a pretty good state. Actually, this thing is now deriving a lot of things that are not necessary, so it shouldn't debug, shouldn't be necessary. Hash either, maybe equals, I don't know. Now it seems that it doesn't. And copy and clone, no, okay. So none of those were necessary. This still compiles, right? So yeah, let's now prune the code then. We have already pruned the execution tree. This is a leftover of some experiment that I was doing when I was dealing with overflows. So let's change this to just simple addition. We don't need to make this saturating add calls. The result should be the same. Oh, it's really nice to have the thing also running in such a fast time, so you don't have to wait a lot of time to get the answer. I feel very good about this now. The parsing, yeah, the parsing was doing this questionable thing also. Can we? I'm all right with this, to be honest. Yeah. So this is the meat and potatoes of all the code, and it's a pretty long function. I'll be honest. There is some repetition and some things that could be improved here. So this is pretty nice. It's explained. These kind of things could be extracted into functions too, but I don't really care. Oh, by the way, maybe there's something that I can do now. We are passing the remaining minutes here as a parameter, but I was thinking, like at some point the remaining minutes had to be a parameter, like something else outside the state, because we were putting this on the cache. But now that we nuked the cache, I think remaining minutes might make sense to have in the state, actually. So let's try that out. So state, we have all of this, and we'll also have remaining minutes. And when we do new, we are gonna take that remaining minutes. So it starts with one or robot and with this given remaining minutes. So here, instead of passing minutes as a parameter here, we create a state with that. Okay. So then instead of accessing remaining minutes here, we access it from the state. We could probably extract it into a variable, but I don't know. Actually, there's a pair of parentheses here that is not needed. Yeah, I want to do this basically to get rid also of these remaining minutes minus 1 here in these calls. So yeah, all of this goes away. And instead of doing that in the recursive call, we can do it when we do new state. No, sorry, not new state, state tick, which is the thing that is advanced, sort of producing. It's basically the simulation of 1 minute of time. So it makes sense to have this decrement of the remaining minutes in this place. So remaining minutes here, it's going to be self remaining minutes minus 1. And with that, I think this should still be the same, yeah, the same result. So okay, before adding that change, I think I want to first commit, you know, the success of like the successful part 1 and part 2 solutions. So day 18, let's say, completes day 18. No, sorry, this is day 19 solution after removing the cache. Let's say after pruning the code tree. Isn't pruning written like this, or is single n? Okay, quite a bit, and removing the cache, which was making things slower because all the hashing due to all the hashing. Now parts 1 and 2 run under 1 second. Okay, really nice. That's the nicest commit I've made in a long time. Biggest win. And now with this is a much simpler refactor. Let's do atomic commit. Put move remaining minutes into state where it wants to belong. Actually, this. All right. There's something else that's this upper bound is asking a lot of things about the state. So maybe this is giving us a hint that maybe this could be a function of the state. Let's see. Help me out, language server. Let's drag this into function. And this is going to be called geode upper bound. And we have the state here. Really cool. Of course, we can move the comment inside of here. And this function, I think, also wants to live in the state. So yes, this is gonna be a self reference, and inside of here, this is just self blah 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 blah. So now this is something that we can ask state geode upper bound. Cool. Again, they should still run. That was a simple refactor. Yes, indeed. And I'm wondering if it would make sense to actually put all of this function inside the state, you know? Yeah, I think it wants to. Let's have blueprint. Oh, I just remember that this thing that parses a blueprint maybe also wants to live inside the blueprint struct. So we have quality level of blueprints. We can have a parse function here. This is just a shuffling code around this. It doesn't make a whole lot of difference, but I sort of like to have code structured nicely. So we have parse here. We can parse a blueprint parse. Very nice. And where were we? Yeah, we can wrap this comment and this thing, move it into state, I think. I don't know about the name, but we shall see. Find max geodes. Yeah, I guess it's fine. But instead of taking a state as parameter, well, it's going to take it, but it will be a self parameter. So inside of here, all state references, all of them should be self references. Right? Yes. And what else? Here we have this new state we have already ticked. So now the calling syntax is more like this, which will please some object-oriented fanatics. And for some reason, it also made the language set, like the formatter, happier, and it changed all of this to a single line, which I appreciate a lot. So really nice. New state and new state. Goodbye. New state by. Okay. And here we can say self tick, which is just wait, and do this. Very nice. Very nice. So this already looks much cleaner, I would say. I don't know if it makes sense to extract these robot making functions. Maybe it does, maybe it doesn't. Does it? Like we are going to try to make these things. When we make a robot, we need to, we cannot like try to make them and then do the tick. It's like, it's important to check first if we can make it, then run the simulation, and then increment this number. So I think I would rather leave this as it is. Also because we are using these Boolean variables for the recursive call. So it's extracting this into a method that would say something like try to make an OR robot, and it would return an optional, none if it couldn't make it because it doesn't have the resources, or if robot, we will still need to keep track of this to pass it in the waiting case. So yeah, I think that this is already much nicer, and without all of the noise of the caching and all of that, this actually looks much better than before. So yeah, this is find max geodes. By the way, we have to update this here. So yeah, this is just create a new state and make it do its thing. Very nice. This triple false thing is maybe a bit ugly, but it's fine. It's the first call of a recursive function, so it's fine to have that. Yeah, I wonder if I could maybe put this in a tuple or something, but it's the same. And now Blueprint has this function of find max geodes in some minutes, but I think maybe this function wants to live in the state itself. Yeah, this takes Blueprint. So let me think. If I would put this call in here, no, it's fine. Yeah, it can live here in the blueprint, and the blueprint can delegate to create a new state and delegate to the state to do the heavy lifting. Yeah. This is pretty good. Yeah, I'm quite happy with this. We have the blueprint and its implementation, and then we have the state and its implementation, and the main code talks only about blueprints. It doesn't talk about the state of the simulation, so that's also pretty nice, layered code, I would say. Let's take a last look at this main code and call it a day, I think. Yeah, and for part one, we are computing the quality levels. Then we are adding those up. And then we are doing part two, first blueprint max geode product. That's a mouthful. I'm tempted to say part two answer because the product is super arbitrary. The quality levels, yeah. And actually, we have these. Oh no, but these are different amounts of turns. Here it's 32, and for the quality level is 24. So yeah, this actually is alright for me. In terms of performance, it's already fantastic that we got to this much lower number. And in terms of code legibility, I'm pretty happy with this. 164 lines of recursion madness. So I think I'm going to commit this. Move, shuffle some functions around to make code cleaner. Very subjectively cleaner. All right. It's always nice when you commit smiley faces, because it's nice. Okay, so I think that's it for today. Oh man, it's already 12:00 It's already midnight and I had to have dinner. But that's it for today. If you have been, thanks for watching and see you next time. Bye bye.